Hello! Today I want to implement dialogues in my game. I want to make a system that can branch out and branch in again so that we can have these nice RPG branching dialogues. So consider this diagram I've drawn of a simple branching dialogue. Okay, each node here has some text and it has a pointer to the next node that also contains some text. But we have a problem now. This node right here asks a question and it has two pointers to the next node, but for a player we can't see what we're choosing here, so we gotta give each pointer some text. Alright, so how are we gonna implement this? To make it a little bit simpler, we're going to give each node an ID, and we're going to assume that the node with the ID of 0 is always the starting node in a dialogue. Great. Now we are able to follow the dialogue through. When we start at node 0, it says hello, and we can only go one place. Now we're at node 1, and it asks, are you a boy or are you a girl? And we can choose if we're a boy or we're a girl, and the dialogue will follow that route. Great. So since each node now has an ID, we can put that data in the pointer, and each pointer will now know the ID that it's pointing to. So a pointer has both this ID and this text that we can show the player. But this is optional because these linear nodes, they don't have a label. So in programming this, we're going to first implement each of these nodes. Contains the information that I've circled here, and we can also express that as these fields. There's definitely an ID, the red number here we see. There's definitely some text in that piece of dialogue. Then we have some pointers, which is now just numbers. And now optionally we have some pointer labels. And there we have that's an entire node right there. Now you may have noticed that there are 3 different constellations of these nodes, 3 different types of nodes. There's this type of nodes, the one with the 0th ID. It's a linear node because it only has one pointer and it is unlabeled. Okay, so a linear node has one pointer and no labels. Then we have this node number 1 here. It has more choices. It's a multi-choice node. So we're gonna define that by more pointers and labels. The amount of labels is equal to the amount of pointers. So more pointers and labels. And finally we have this node number 4 type here, which is an end type. And the end type has no pointers and no labels. This is going to come in handy later when we want to traverse this dialogue tree. We can clearly see if it's linear or multi-choice. To begin with, we know how to handle the case of this node. Alright, I've already written this code because I don't want to waste your time by typing out all this. This is a dialogue node, and in the image here I showed you we have this we have a string ID and an end ID and a string text and some pointers and some pointer labels. Okay, these 2 array lists here are pointers and pointer labels. They're array lists because it's easier to create these nodes if it's array lists, because they can shrink and they can expand. We have this string text and an ID. We also have this node type. That's the type I tried to explain in here, where it can be linear or multiple choice or end. This is just an enumeration used for marking each node. When you create a node, it has to have text and it has to have an ID. So that's why that's in the constructor. So right off the bat, when you create a node, it's going to be a node end because it has no pointers and it has no labels. So right when it's created, we say it's an end. node. Now we have a choice here. We can add a choice to a node that is the same as adding one of these pointers over here. A label, no, sorry, a pointer with the ID, and then a label for that pointer. That's what that method does. You can see here, if it's linear already, that means there's one pointer and no labels. We clear the pointers because we don't want an unequal amount of pointers and labels unless it's linear. So that's a failsafe. Now we add the label that we specified in the parameter, and we add the pointer, the ID of the next node, and then we set the node to multiple choice. And we can also choose to make the node linear. In that case, we clear the pointers and we clear the labels, so we start out fresh, and then we have this node ID that we want to point to, so we simply add that to the pointers and we make the type linear. Now for traversing this dialog tree, we also have these pointers. We can get these pointers and we can get the labels, we can get the type and the text and the ID, just as you would expect. Great. But these are simply nodes, individual nodes. How do we represent an entire dialog tree? Well, that's very easy, because now each node contains information about where it leads. So we only really need a big structure to put all these nodes inside. What we could do is we could put each node inside a giant array list. That would be simple. What I've chosen to do though is put them all inside of a hash map and then index them by their ID here. So that way I don't waste any space by having a dialog with a missing node if a node is to be pulled out later. But it could as well just be an array list. We can take a look at the dialog here. It's just a map, and we can get the node by ID, or we can add a node by specifying the dialog node, or we can get the ID of the starting node, and we'll just return 0 here always. Great. So now we need to expose an API that allows us to easily walk this structure that we've created. And for that, I give you the dialog traverser. It has a dialog, which is just the hash map with all the nodes, and then the current node that we're currently on. And when you make one of these, you have to specify what dialog it is going to traverse. It just sets that internal dialog, and it gets the first node, the starting node, as the current node. And now it only exposes an API that we can easily use to traverse the structure here. We can get the next node by following a specific pointer index that is just one of these arrows. Because we store these pointers in an array in each node, we can reference each pointer by their index in that array. So whenever we want to get the next node here, we specify the pointer by their index. And then it will get the next node in the dialog, which is just the current node's pointers and then the index of that list. It says that node to the next node here to the current node and returns it. Okay, so that way we can go through the tree always by specifying what pointer we want to follow. And at all times when we are standing on a node, the current node here, we can ask what are the options, and this will return the labels. So for this node right here, the options would be boy and girl. And for most linear nodes, for all linear nodes, the options here would be none, because there's only one pointer that has no label. Now text, every node will have text because we put that in the constructor up here for the dialog node. So we can always see what text is displayed when we want to make a choice, and then we can see what node are we currently standing at. So it's a very slim dialog traversal that just keeps track of where you are in the dialog tree here and presents easily accessible information about what are the options and what can we do from here. What is really driving this dialog system forwards though is the player's input. And so for that I've made this dialog controller, which is in libdx just an input adapter. And now it has its own dialog traversal, and it has a dialog box and an option box. These last two are UI elements that I've already done a video on, but I'll put a picture of them up so you can see what these UI elements are. We can control these by a very simple API. We'll encounter that later in the code. When we create the controller here, we want to specify what dialog box and what option box we're going to use, because we're going to reuse them for each node. Great. Now I've only implemented a few methods here, mainly key down and key up. The key down is very straightforward. If the dialog box is visible at all, then I don't want any events to propagate down through the input system. So for that reason we return true here, so that we intercept the event from propagating down. If it's not visible at all, we can just let that event happen. Great. Now the key up is where stuff actually happens in this dialog system. First off, we want to know if the option box is visible. That's the box containing the options for nodes that are multi-choice. If the up key is pressed, then we move the cursor on the option box up, because we want the player to control what option he chooses by moving the cursor up and down with the up and down key. Great. So if that happened, we return true because we handled that event. Same goes for down. Now, if the traversal is not null, that means there is a dialog currently happening, and the key code that was pressed was the key X, and the dialog box is finished. This means the dialog box is no longer animating the text rolling out. Then if all these three things happen at the same time, that means we're ready to progress through the dialog system. So what we do here is we ask the traversal what type we're currently on. If we are on an end, we simply destroy the traversal and hide the dialog box. Now if the type we're currently on is linear, then we know there's only one pointer and it will have an index of 0. So we just progress through our dialog following the 0th pointer. Now this progress is implemented later in this code, so we'll get there. If it's not linear though, it must be multi-choice, and that's the last if we're gonna do here. If it is multi-choice though, we're gonna get the option box, and we're gonna get what we're currently standing on with the cursor, and we're gonna progress using that pointer. And if any of that happened, we'll return true because we handled the event. However, if it did not, then we still want to check if the dialog box is visible, because if it is, then we don't want the event to spread down through the system. The update method here is only here because I wanted the option box to display after the text had finished rolling out on the dialog box. So that's what's going on here. We're simply checking if the dialog box has finished animating and we actually are traversing something, meaning we have a traversal. Now if the traversal, the type of node we're standing on now is a multiple choice, and the dialog box is finished, of course, then we set the option box visible. Great, it's a little detail. Now the progress function that we saw earlier here. When we progress, we choose the index of the pointer we want to follow, and then we the first thing we do is set the option box invisible, because we don't know if the next node is going to have options or not have options, but either way we want to start out by not having it visible, because we are only making it visible when the text is finished rolling out anyway. So in no circumstance would we go through to the next node and have a visible option box. Then we find the next dialog node here, and we get that from the traversal and the index that we chose. Now the dialog box will animate the text on that next node to roll out. And if the next node is multiple choice, then we add each of the options to the option box. But we clear the option box of choices first. Great. Now the only thing we're missing is how do we start a dialog using this dialog controller. Now when we started, we only specified the dialog box that we're going to use, the UI element and the option box. So we start a new dialog by calling this start dialog method with the dialog you want to start. So we make a new traverser using this dialog, and then we set the dialog box visible, and we animate the text inside the node that we're currently standing on, which would be the node with the ID of 0 when we're just starting out here. And if the current type is multiple choice, then we add the options to the option box again. The reason for this dialog traverser, I should have said, is so we don't have any of the temporary information about where we are in the dialog inside the actual dialog, because we may want to reset it. We may want to talk to the same person again following a different route through the dialog. Then it's just easier to have this dialog traverser and then feed it the dialog from a dialog bank, and then having this have information about where we are and where we go. Now I'm in my game screen here. This is where everything is drawn, and the whole game takes place here, pretty much. So in the constructor here, I've gone ahead and I created this dialog. This dialog right here. It's a new dialog. It's not going to contain any nodes. And then we make some nodes here. We have a first node, hello, nice to meet you. And then we have the next node, are you a boy or a girl? This is very similar to the example from the beginning. And then the next node, I knew you were a boy all along, or I knew you were a girl all along, depending on what the player chose. You'll notice now each of these dialog nodes here have an ID, and so the 0th one is the first one. Okay, then we go inside this node and we make that linear. We make that point to the ID of node 2. And in node 2 we want to have options, so we add a choice boy and make that point to 2, and then we add the choice girl and make that point to number 3. So it's these two that is pointing to, these two dialog nodes. Finally, we put each node inside the dialog, and then we have the dialog controller here, and having it start the dialog. The dialog controller is created up here after the UI is initialized, because then we have the dialog box and the option box to play with. Now I'll show you what it looks like when we do this. It says hello, nice to meet you, and I press X. Are you a boy or a girl? And then the option box pops up. This is what the update method does. And now, since it is visible, we are now receiving events for it. That's what's happening up here. Okay, then we choose a boy. It says I knew you were a boy all along, and because this node, when we initialized it right here, I knew you were a boy all along, this node 3 doesn't lead anywhere because we didn't specify it to lead anywhere. So this will be a node of type end. And then when we press X, we know what happened. You know what happens when we press X and it's a type end. Then the traverser will be destroyed and our dialog box will be not visible anymore. There we go. Great. So that's how the branching dialog works in this game here. Thank you for watching the video.